Today you will recognize arithmetic sequences and relate arithmetic sequences to linear functions. So first of all, we have a few vocabulary. A sequence is a set of numbers in a specific order. Terms are the numbers in the sequence. An arithmetic sequence is a numerical pattern that increases or decreases at a constant rate or value. The difference between successive terms of the sequence is constant. So let me translate that. You're going to have a common difference. The difference between all your terms is going to be the same. And then common difference is your last term, and it is the difference between the terms in a sequence. So the first thing that you're going to do is look at a sequence and determine if it's arithmetic or not. So we need to look to see if it has a common difference. So this is plus 2, plus 2, plus 2, plus 2. So we would say yes, and we would say plus 2, because the common difference is adding 2. And if you looked, you would see that yes, it's adding 2 each time. How about here? It looks like it's going down by 4. This is going down by 4, down by 4, down by 4. Is this? We would say yes, because it's subtracting 4 each time. So it is arithmetic if it has a common sum or a common difference. Let me give you an example of one that is not. If you look here, this is a difference of 2, or adding 2, I should say. This is adding 3, this is adding 6. So this would be a no. And then you wouldn't have to say why it's a no, it's just no.
Mrs. Gerard, please come to the office. Mrs. Gerard,
let's check this one. It looks like from here to here is a plus 2, from here to here is a plus 2, from here to here is a plus 2. So we would say yes, and it's plus 2. In this situation, since it's fractions, maybe you want to use your calculator to check. 1/2 to 5/8, I'm going to cheat a little bit and look here. This is plus 1/8. This is plus 1/8. When you subtract this, you get plus 1/16, and you can check that on your calculator. So here we would say no. And we don't have to say why it's no. But we can see here that I don't have a common difference. It's not adding 1/8 each time. All right, let's move on. Find the next 3 terms. So in this arithmetic sequence, we have to find the common difference first. So it looks like it's subtracting 6, subtracting 6, subtracting 6. So we're going to go down 6 from here, which would be -9. Down 6 more, -15. Down 6 more, -21. So we just found the next 3 terms by using common subtraction. How about here? This is going up. Up 3, up 3, up 3. So the next term would be 20, then 23, then 26. Finding the next 3 terms can be easy when you know the common difference. Now, can you see a pattern here? Let's look and see. It looks like this particular example, the first term was 8. The second term was 11, which is 8 plus the common difference, which was 3. The third term was 14, which is 8 plus twice the common difference. 8 plus 6, right? So this pattern will continue. So I can have a formula for every arithmetic sequence. And here's what it is. It's going to be the first term added to this number of the term you're looking for, -1, times the common difference. So in this example, it would be 8 plus whatever term you're looking for, -1, times 3. And here's why that's important. We can use this formula to find any term at any time. So let's write an equation for this sequence. What is the first term here? -12. What's the common difference? If you look what's happening each time, it's adding 4. What term are we looking for? Well, right here we're looking for the nth term. So this would be n. So I'm going to plug this into this formula. A sub n is equal to the first term plus n minus 1 times 4. Now, you could leave it in this form, but I think we should try to simplify it. So this would be -12 plus, let's distribute this because it's just multiplication, 4n minus 4. Now I can combine these terms, so this is -16 plus 4n. So a sub n is equal to -16 plus 4n, or you could rewrite that to a sub n is equal to 4n minus 16. Either one is fine. Once you get it in this form, if I want to know the 9th term of the sequence, all I have to do is say, hey, if I want the 9th term, I do 4 times 9 minus 16 because n stands for the number of the term. 9 times 4 is 36 minus 16, and you subtract that, and you get 20. So the 9th term is 20, and you can say a sub 9 is 20, or you could say the 9th term is 20. So which term of the sequence is 32? Well, I would say 32 then is equal to 4n minus 16. Add 16, and you get 48 is equal to 4n. So n, when you divide by 4, n would be 12. So the 12th term would be 32. Please watch that again if you're not understanding. One thing that you can do is graph the first 5 terms. Well, what I know here is that if this term is 1, it's going to be negative 12. So you can count by 2s. 2, 4, 6, 8, 10, 12. The second term, you know, is going to be negative 8. So 2, 4, 6, 8. The third term, you know, is going to be negative 4, 2, 4. The fourth term is going to be 0. And then the fifth term would be 4, positive 4. And I'm going to count by 2s here. So you should notice a couple things. You don't have to connect them today, but they are linear, so you could. And something else that you'll notice is that they have a common difference of 4. Watch. Rise 4, run 1. Rise 4, run 1. Rise 4, run 1. Rise over run. You guessed it. Your slope is 4. 4 is your common difference. 4 is also your slope. See how it's linear? See how it goes together? So I've got one for you to practice here. Here's a real-world example. Carly is mailing invitations to her friends for a party, and the sequence is 42 cents, 84 cents, 126, 168. And that's the cost of postage. So let's write a function to represent this sequence. So the first term is 42 cents. What's our common difference here? Well, it looks like our common difference is also 42 cents. And it also looks like we're going to leave n as n. So the number of the term or the number we're looking for. So a sub n is equal to a sub 1 plus n minus 1 times d. Now remember, we can't leave it in this form. We are going to have to distribute and simplify it a little bit. So 42 cents plus 0.42n minus 0.42. Well, what do you notice about these two? Do you see how they're going to cancel out? So you're left with a sub n is equal to 0.42n. So this is our equation to represent this sequence. So if we wanted to graph it, if I put in a 0, obviously 0 times this is going to be 0. This looks a lot like a direct variation equation that you did yesterday. So 1 is going to be at 42 cents, 2 is at 84, 3, and so on and so forth. It's going to be linear. And you don't have to connect it, but we could, but we don't have to. We just needed to graph what we have so far. What is the domain? Well, the domain right here, your x values, are the number of postage that you're buying. So one letter, 2 letters, 3 letters would be that amount of postage. So you'll have one real world problem to try in your notes.